In this video we're going to begin a new topic of polynomials, and today we're going to look at the introduction to polynomials and evaluating them. So a polynomial is an expression with one or more terms of this form. So you can see here that for each term we have a constant and then we have an x term, and x is raised to a power here. So you can see that the power of x is decreasing each time, potentially until we get to 0. Now, we know that each term has the coefficient, like I said, and it's followed by that x term or any variable, and it's raised to a whole number exponent. So n here has to be a whole number, and as I said already, it decreases as we go on. Now, we've actually already seen polynomials before. You are familiar with quadratic expressions, where there's an x squared term. So this isn't totally unfamiliar to you. So if we just have a wee look at this one, we've got 3x to the power 5 plus x cubed plus 2x squared minus 6. And that is a polynomial of degree 5. And that's because the highest power of x is 5. If we look at a quadratic, those are polynomials of degree 2. So we just look at these last three terms here, for example. So that's a quadratic there. It's got an x squared term. And you can see that the square term is, the 2 is the highest power of x. So that's why it's of degree 2. And finally, actually, if we've just got a constant, those are actually polynomials as well. Those are polynomials of degree 0. And that's because we know that anything to the power 0 is equal to 1. So if we had, for example, the expression and it just said 6, then we would know that was a polynomial of degree 0. So, just a task for you just now. So I've given you a series of polynomials here on the left hand side. I want you to tell me what the degree is. And then for the last two, I've given you the degree. I want you to come up with a polynomial which would fit in there. So if you pause the video at the moment, and you can complete this task, and then we can come back and look over the answers. Okay, welcome back folks, and hopefully you got on okay with that. So this first polynomial, 4x squared plus 2x plus 5, we can see has degree 2, because the highest power of x is 2 here, this x squared. The next one, 4x to the 4 minus x cubed plus x squared minus x plus 1, we can see has 4 as its highest power of x. 3x squared, that's degree 2. 2x plus 1, well, that's degree 1. Just the x term, and that's raised to the power 1, even though we don't write that in. Now, x minus 1 all to the 4, so when we expand that, the highest power of x, we would have an x to the 4 term, an x cubed, an x squared, an x to the 1 and an x to the 0 term. So we can see here that the highest power of x is 4. This one here, the highest power of x is 5. So you can see it's not always, the highest power of x isn't always in the first term. So just be aware of that as well and look out for it. The polynomial expression 5, that has degree 0. And hopefully you've now made up two polynomials at the end. So for degree 3, you could have any cubic, so something involving an x cubed term, and any other x that you have in there has to be, for example, x squared, x to the 1, or a constant term. So it has to be less than a cubic, basically. And finally, if you've got degree 6, you can have any sextic. So any expression with the highest power of x being 6. Okay, so moving on slightly then. So you've had the introduction to polynomials, so let's look at evaluating them. And we can evaluate polynomials using substitution. So for example, if we take f of x, which is defined by 2x cubed minus 9x squared plus 2x plus 1, and we evaluate f of 5, we will get 36. Okay, so basically we are substituting in 5 in place of x. So everywhere there's an x, we're putting in 5, and you can see what that would look like here. 2 multiplied by 5 cubed minus 9 times 5 squared plus 2 times 5 plus 1, and that gives us 36. Well, we know that f of 5 is 36, but actually it means that if we divide f of x by x minus 5, we have a remainder of 36. So let's have a look at some other examples then. So given that g of x is equal to x cubed plus x squared minus 22x minus 40, evaluate the following and state the remainder. So we are asked to evaluate for part A g of 3, for part B g of negative 5, and for part C g of negative 2. So part A, firstly, we were asked to evaluate g of 3. So we're taking our expression for g of x, and everywhere there's an x, we are substituting in 3. So we have 3 cubed plus 3 squared minus 22 times 3 minus 40. And that gives us negative 70. And that also means that our remainder is negative 70 when we divide the function g of x by x minus 3. For part B, g of 5, we should get 30 when we substitute negative 5 into the expression for g of x. And that means the remainder is negative 30 as well. And for part C, g of negative 2, when we substitute that in, we actually get 0 this time. That means that there is a remainder of 0. Now, if there's no remainder when you evaluate f of a, i.e. f of a is equal to 0, this means that x equals a is a root of f of x, and therefore x minus a is a factor of f of x. So in the previous example, we had g of x being equal to x cubed plus x squared minus 22x minus 40, and we worked out that g of negative 2 was equal to 0. So that means that x equals negative 2 is a root of g of x, and therefore x plus 2 is a factor of g of x. And then we can use that to help with factorisation. So we have our expression for g of x, and we then know that g of x is the same as x plus 2 multiplied by some quadratic in this case. Because if we multiply a quadratic by a binomial, x plus 2 here, then we're going to get a cubic. So, I'm going to do a task just now. What we've just talked about, we will cover more in following lessons, but just to aid you to get there and develop your understanding of what we've talked about with roots and factors, it would be good for you to try this task. So there's an example here. If the root is x equals negative 2, what is the associated factor to that? And in the first example, that is x plus 2. So if you pause the video and try and fill these in your notes, and then come back and we'll go over the answers. Okay, hopefully you got on well with that, folks. So the first one here, the root is x equals 5. Hopefully you got that the associated factor was x minus 5. For x plus 7 as the associated factor, then the root would be x equals negative 7. For x minus 7, the root is x equals positive 7. For x minus 3, the root would be x equals 3. And then we've got the root x equals negative 3. So that means the associated factor is x plus 3. For 2x minus 1, the root, obviously if we make 2x minus 1 equal to 0, we can then solve that and we can get x equals 1/2. For x equals a third, we would get 3x minus 1. For 2/3, 3x minus 2. And for our associated factor of 4x plus 5, we would get a root of x equals negative 5 quarters.